In this session, I'm going to introduce to you the degassing function of our new SPS 2000. This is one of the new features that we've introduced with this machine. And you may ask, what is degassing and what is it for? You know that all powders, they are saturated with moisture and other volatile compounds, impurities. And when you apply a conventional sintering, you start with a high pressure, maybe 50 or even 100 megapascal, and then you apply your temperature to the temperature you want to reach to sinter this material. In that case, what happens then during the process is that these compounds try to escape, and that can cause, of course, a lot of cracks and fissures in the sinter material, which might prevent you from reaching the highest density. But during our degassing process, you can try to avoid that. You start with having your powder in the die, and then you, under low pressure, you heat it to maybe 150, 200 degrees. After that, you lower the die and you let these evaporated substances disappear. And then you put it back again, apply a low pressure, and start heating it again. And you can do this for a number of cycles. After that, you have removed all these things, and you can sinter your clean powder to your final temperature, and you can reach the full density. I have now mounted the sample here in the chamber. There is a special lower spacer that sits here, and in that one we have inserted the lower punch with the die with the powder. When I press these two buttons, I can make the electrode go up so that the die goes up and the upper punch touches the sample, and we make now good contact with the upper spacer here. So we have electrical contact. We also now are using a thermocouple here that sits in the hole in the die and measures the temperature. To show you one more very interesting feature is that we have here a LED light inside the chamber, and that is very, very convenient when you try to focus the parameter out here when you use a parameter for temperature measurements. I have now loaded the sample and closed the lid, and it's time to start the sintering process. This window shows you an overlay of the whole SPS machine. What is important now is this window, parameters here, because here we set the parameters for the degassing. First of all, we have a pressure that we apply to use the degassing function. This is very low force, just 1 kilonewton on a 15 millimeter die, not to compact it too much. We have also selected now the heating temperature, so we'll heat the sample up to 150 degrees. We keep it there for 20 seconds, and then we lower the sample again, and we let it vent for 30 seconds. And we can repeat this 3 times here. And of course, all of these parameters can be exchanged. In this window, we also have the PID settings for this regulation. In the second part of this window, we have now the selection of how to do the pulse generator. Now this is on-off sintering, like all SPS machines has been working now for more than 30 years. In addition to this, we have here a continuous DC, or we have also a full wave function. And these two also requires their own sessions to be displayed. And the third part here is for the post-sintering parameters, where we can have a rapid cooling, and I will come back to that as well. But let's consider that we have now selected these parameters for the degassing in this case. The sample here is a zeolite, a very fluffy powder with a lot of surface area and a lot of moisture in it. If I go back to the operation windows, we can take a look at the recipe that we are going to follow. We start by just increasing the pressure to the 6 kilonewton, which give us 40 megapascal, and then we sinter up to 625 degrees, 700, 750, and keep the temperature there for hold on. This is rather conventional, but this is now done after the degassing. So I'm back here, I look at the operations table, and now we can start the sintering process just by pressing auto start. We have reached our target, and now this 20 seconds for holding it has finished. The current is turned off. You see here now that the lower die is going down. The value here increases. And all this evaporated moisture and impurities can now leave the system, be pumped out. And now the die starts coming up again, and the upper punch finds its position in the die. And there it makes contact, and the next heating starts in the next cycle. This is now the last sequence. We have the third degassing cycle, which is now finished. The die is moving down again. You see the Z axis here counts down until it reaches about 51 millimeters below. Now it's finished by venting. It goes back again to make contact and go over to the sintering program. So you can see that this set value of the pressure will change here when it reaches that position. And the first minute here, it increases the pressure up to 6 kilonewton, which will give us 40 megapascal of pressure. Now we get into the second step of this program, and now the temperature starts counting from room temperature, but we are already, because of the degassing, at over 90 degrees. So it will take some time until we need some current to continue the heating. When the blue temperature figure is passing by the green, that will create a demand for electricity for heating. Now it is surpassing that. The requested value is now almost 90 degrees. Now you see that the current starts kicking in here, and the temperature will start rising in the sample, which now starts here with the green digits for present value of temperature. And from now on, it's a completely normal sintering procedure. So we will not follow that whole sequence in this section.